Now, this is the third part of this part D, and we'll continue with another example of an aqueous electrolyte. Now, in this case, we are going to look at dilute copper 2 sulfate. And again, four ions will be present: Cu2 plus H plus for the cations, and SO42 minus and OH minus for the anions. Now, your two cations will be attracted to your cathode, and in this case, because Cu2 plus is below H plus in the reactivity series, therefore your copper 2 ions will be discharged as copper atoms, and you'll see the electrode having a reddish brown coating, and that is the presence of your copper atoms. Now, at the anode, because this is a dilute solution, therefore your hydroxide ions will be discharged, and you will see oxygen bubbles of O2 at the anode. Okay. Now, next, within the electrolyte, what is happening is because your Cu2 plus and OH minus are being gotten rid of, what it remains will be H plus as well as SO42 minus, and this actually produces your sulfuric acid. This means your solution becomes more acidic over time. And in addition, the electrolyte will fade from a blue color to a more colorless kind of appearance because your copper 2 ions are being discharged, and over time the concentration of Cu2 plus decreases. Therefore, the solution becomes less blue. And the next scenario we'll look at is concentrated aqueous to copper 2 sulfate. And same thing, the four ions here are present in the electrolyte. Your cathode, no change as well because Cu2 plus is below H plus in the reactivity series, therefore it will be discharged as copper atoms. And at the anode, between sulfate and hydroxide, now even though it is concentrated, but remember sulfate ions are never discharged, therefore hydroxide ions are still the ions being discharged as O2 and H2O. And in the electrolyte, again, there is actually no change from the previous dilute case. Your H plus and SO42 minus are still left behind, and the solution still becomes more acidic. And the electrolyte again will change from a blue color to a less blue or eventually a colorless solution. Because anyway, your H2SO4, which is left behind, is a colorless solution. And this brings us to the end of this whole part B of your electrolysis. And again, we have, just to recap, we have looked at the various scenarios. We have looked at the molten electrolyte, the aqueous electrolytes, and all these with the inert electrodes. We are also going to be looking at reactive electrodes as well as applications of electrolysis in the next video coming right up. Thank you. And leave a comment below to if you want me to analyze or go through some examples of molten or aqueous electrolytes, and to discuss about the various products at the cathode, the anode, as well as within the electrolyte itself. So that's all. Thank you so much.